I make sure Patty Mahomes doesn't lose.
Okay. Now, here's going to be the next step. So on the back side, I'm going to show you exactly how I want these problems done. Now, here's my absolute word of truth to you. When I show you how to do a process, I am always going to show you the fastest, most efficient way to do a problem. Okay? I'm never going to spend an entire day showing you how to do something. And then the next day you walk in, I'm going to go, oh, forget about that. You can do it in one step. Okay? I promise you, I am never going to do that. And when I show you how to do a step, when you look at my answer keys, this is how I do these problems. Okay? Word of truth. So on the back side, we want to add vector B to vector D. So what I do, Thatcher, is that I make a sketch. Okay? I don't have to, but it at least tells me an idea of what's going to happen. So I know when I add vector B to D, and again, this is just a sketch, I know that resultant angle has to be more than 180. Dylan.
We've already done all these shapes. You just want to add on to shapes right here, or just ignore that?
No. You can just use them as a reference. Okay? But we're going to use trig functions to find the value. So here's the first thing that you need to do. Set up a chart of your x components, your y components, and then the sums. Okay? This forces you to stay organized, and it makes it easy for me to grade, because then I can see exactly what you've done. Now, you already have these on the other side. You don't have to recalculate them. We already have them. So, what's B's x component? 0. Okay? Big goose egg. What's B's y component? 3?
I wouldn't know for a second. I think that's all it is.
Okay. What's D's x component? Off of your trig functions that you just did. What's D's x component? Negative something. Negative 3 point what?
2.05.
Or negative 2.05?
Yeah, that's what they got for vector D.
And then what do you have for the y component? Negative 5 point what?
6.4.
If you also want to include units, or just ignore that?
No, if you don't have to, because I know these are all centimeters.
Oh.
So you get a negative 2.05 and then negative 2.64. Okay? You're just going to add these together. All you're going to do is just add the columns. Okay? All you have to do. So here's, if you're a visual kind of person, let me kind of show you what's happening. If you started at this origin, and again, this is just a simple sketch, you're going to go out negative 2.05 centimeters. From the end of that, you're going to go up 3, and then you're going to go down negative 5.64, and you're going to end up here. Okay? Now, here's the beauty of this. Now, I've got a right angle. Now I can use tangent. Now I can use the Pythagorean theorem. That's the whole point of the story, is so that I end up with a triangle that's a right triangle. That's where we're at. So, here is, if you ever do a sketch, Thatcher, if you ever do a sketch, you do a sketch using these. So just come out here and go, okay, I always draw my x's first, and then I got negative 2.64. Now, for now, I want you to pretend that this isn't there. I'm going to get back to it. Pretend that this is not there. I'm going to come back just for a second. So imagine that you had 2.05 and 2.64. Let's say those numbers had been positive. Okay? Let's start with a simple. Let's say they've been positive. So Connor M. I know the side opposite is 2.64. I know the side adjacent is 2.05. What trig function could I use to find that angle?
Just x over sine equals.
No, you don't use sine, because I don't know the hypotenuse. Let me give you a hint, it rhymes with tangent,
Tangent.
okay? Because the tangent of an angle is gonna equal what?
Y over x.
Yeah, opposite over hypotenuse. So 2.64 over 2.05. So again, old school, this is what I would do, old school. Somebody take 2.64 and divide that by 2.05. Just give me the number.
1.288.
What'd you get?
1.288.
So then, on the old school method, I would go to this column and I would find a tangent value of 1.28, which corresponds with an angle of 52 degrees. Okay, so you would actually divide it out, get the value, go to the table, find what angle was close to that, which is 52 degrees. Now, conveniently, your calculators handle that. So you're just going to type in inverse tangent of 2.64 over 2.05. What do you get as an answer?
52.17.
So 52.2 degrees. Okay? Cool, 52 point, it was pretty close to what this had. That had 52 degrees. But that only went to like the nearest whole degree. Okay. Now, 52.2 degrees, that's cool, it's in that first quadrant. Now, this is where your calculator will lie to you. Okay? And you're going, Mr. Burkett, my calculator won't lie to me. Yes, it will. So you're trying to find this angle. Okay? Now, here's what I want you to do. I want you to take your handy-dandy calculator and type in the inverse tangent of negative 2.64 over negative 2.05. What does your calculator say the answer is?
52.17.
52.2 degrees. So according to your calculator, the resultant of these vectors is up here. Seem reasonable?
No.
No, this is why you make a sketch. Now, legitimately, is this angle in here actually 52.2 degrees? That's 52.2. It is. That's 52.2 degrees. But that's not the angle that I need. What do I need? I need the angle from that positive x-axis. So what am I going to do? Add 180 to it. Okay? This is where your calculator lies to you. Your calculator does not handle quadrants and how physicists handle angles. Okay? I got caught in a loop there. So, what are you going to do? Take the 52.2 and add 180. What are you going to get?
232.2.
Yeah, whatever you get for that angle. So here's another situation where your calculator would lie to you. Let's say that you had ended up with negative 2.05 and 2.64. Let's say it was in this quadrant. Now, somebody take the inverse tangent of 2.64 and divide that by negative 2.05.
Negative 52.2.
You get negative 52 degrees. Can you have a negative angle?
No.
Not in physics.
No. So this is what I do. And again, I'm old school because of my training on how I learned how to do this. If it were me, I wouldn't even punch in those negative signs. I would not even touch the negative signs. I'd just find the angle and then decide, hey, do I need to subtract it from 180? Do I need to add 180 to it? What do I need to do? I would not even mess with punching negative signs into there. okay? So here's what I want to see on a problem like number 10, okay? If you want to do this initial sketch, so you get an idea of where you're going to end up, cool. If you don't want to, that's up to you. That's on you. But what I do want to see is a chart like this. This says, here's my x components, here's my y components, here's the sum. At a minimum, I want to see that chart. Because if your answers are wrong, and all I see is a bunch of random numbers off to the side that doesn't make any sense at all, I care for you all deeply. But I am not going to waste my time trying to sort through random numbers. Okay? Not going to do it. I got better things to do with my time. Okay? So, beg if you draw the chart. I strongly recommend that you draw a new triangle once you get those x and y components, because then that shows you what quadrant that's going to be. That'll make more sense. So here's what I'm done. So this whole thing is due tomorrow, okay? So you got 11, 12, 13, 14. Again, draw the charts. I beg if you draw the charts, okay? Look at my answer keys. Literally, when you look at my answer key for this assignment, every problem has a chart. So, because it makes life simpler. Okay, stop you on the camera. You're on your own.